Okay, let's jump right into this explainer and take a true expert look at the hidden realities of commercial interior graphics. When we're evaluating large-scale commercial spaces, walls are so often just taken for granted as blank canvases. But the materials we choose to cover them actually have these massive compounding effects over time, and that hits both your operating budget and the environment. So what is the true cost of a beautiful wall? Well, it's incredibly common for people to only look at the upfront aesthetics, right? They see a nice pattern or a really vibrant color and stop there. But if you're doing a comprehensive expert analysis, you have to calculate the full life cycle waste, the chemical disposal, and the severe operational downtime. That real cost rarely shows up on a facilities manager's initial P&L statement, but it absolutely dictates the long-term sustainability of the building. 3 tons. Just let that sink in for a second. That staggering number is the amount of physical waste generated from removing and replacing standard wallpaper during a typical 5,000 square foot office renovation. Literally 3 tons of material heading straight to a landfill simply to refresh a single office floor. And honestly, the terrifying part is that this isn't some rare anomaly. This is the widely accepted industry standard life cycle for traditional commercial wall coverings. Section 1. The illusion, hidden costs, and predictable failures. Let's break down the fundamental chemistry behind these approaches. Traditional vinyl relies heavily on energy-intensive petrochemicals, like PVC, and these really harsh toxic adhesives. But direct-to-wall printing? It is a total paradigm shift. It relies purely on industrial pigment, a protective sealant, and the building's existing architecture. By completely skipping all those intermediate materials, you're eliminating a massive chunk of the environmental footprint right at the source, way before the installation even begins. And the problem isn't just how it's manufactured, it's how it actually performs. In demanding environments, think healthcare facilities or crowded schools, these conventional materials rapidly bubble, stain, and fail. We see them peel heavily in high moisture areas. Their seams completely deteriorate under routine cleaning protocols, and they can even harbor dangerous mold growth in poorly ventilated spaces. Because of these built-in structural vulnerabilities, they're typically doomed to a limited 5 to 7 year lifespan, which just forces an expensive, highly disruptive cycle of constant replacement. And speaking of disruption, let's look at the reality of a traditional install. Step 1 is intense substrate prep. Step 2, slathering on chemical adhesives. Step 3 requires meticulous edge finishing just to hide those visible seams. And then Step 4 demands a full 24-hour cure time where nobody can even use the space. This tedious multi-day process means cordoning off busy hospital corridors or shutting down school cafeterias for up to 5 full days. That creates massive operational bottlenecks that cost institutions thousands in lost efficiency. Section 2. The disruption, molecular bonding, and zero waste. So how do we fix this? Well, we solve it not with a better sticker, but with a fundamental shift in material science, molecular bonding. This is a groundbreaking process where industrial-grade pigment and sealant permanently fuse directly to the drywall, concrete, or brick. It entirely eliminates intermediate materials. By printing directly onto the substrate at an architectural scale, we wipe out the physical vulnerabilities of vinyl. You get a stunning surface with absolutely no seams, no peeling adhesives, and no toxic off-gassing in occupied buildings. And this leads right into what is arguably the ultimate sustainability feature of direct-to-wall technology. It gives you a completely paint-over-ready finish. We're talking zero chemical strippers and absolutely no wall damage. When it's time for a refresh, because, institutional branding always changes eventually, you just paint over it with standard latex paint. You don't scrape, you don't apply harsh chemicals, and you definitely don't fill a dumpster with toxic debris. The wall is immediately primed and ready for its next iteration. But this innovation doesn't stop at the wall itself. It completely reshapes the supply chain. Traditional logistics require prefabricated rolls, heavy protective packaging, and multiple trucks driving all over the country. By utilizing on-site printing, we strip out the massive carbon footprint of that supply chain. We're bringing architectural scale printing technology straight to the job site. So a mural that used to require 3 truckloads of vinyl and packaging now just travels as concentrated ink and mobile equipment in a single, highly efficient trip. Section 3. The expert proof, real-world operational data. Okay, theory is great, but as experts, we know hard numbers prove the case. 12 tons. Over just a 5-year period, a 400-bed healthcare network eliminated 12 tons of vinyl waste simply by switching their multi-building wayfinding to direct-to-wall printing. Plus, they compressed their installation time from 40 working days spread across 2 months
down to just 12 working days. That is a literal game changer for hospital operations, where patient flow is absolutely critical. Here's another massive metric for you: 68%. A major university deployed this exact technology across their academic, residential, and athletic facilities. When they rigorously tracked their sustainability metrics, they achieved a massive 68% reduction in chemical use compared to their old, outdated Waller program. And that same university, they also slashed their labor hours by 45%. Why? Because when it was time to change a space, the graphics were simply painted over rather than being laboriously stripped, scraped, and repaired. The underlying wall prep was perfectly preserved, which ended up saving them thousands of hours of facility maintenance labor.
So the real operational takeaway here is that installation time is completely slashed. We go from 3 to 5 days down to under 5 hours. Think about that. A standard 2,000 square foot mural now takes less than 5 hours, allowing the facility to remain fully operational. No rerouting patient traffic, no closing down cafeterias, and definitely no wasting energy running temporary dual facilities while one is stuck in a construction zone.
Now, you're probably wondering about longevity, right? Well, while vinyl generally deteriorates and looks pretty awful in 5 to 7 years, our data proves that 94% of direct-to-wall finishes easily surpass the decade mark, even in high-traffic areas. That's because the design is fundamentally performance-based. It accounts for heavy foot traffic, moisture, and strict hospital-grade cleaning protocols right from day one. Section 4. The bottom line: calculating the 10-year life cycle. True financial planning means we don't just buy for today, we buy for the decade. While direct-to-wall might cost slightly more on day one, usually ranging from $22 to $36 per square foot versus $18 to $28 for vinyl, the total elimination of expensive chemical removals changes everything. The 10-year totals actually end up nearly identical. But the real magic happens at year 15, where your savings multiply massively because you aren't paying for a full material replacement. I absolutely love this perspective. Durability is the most underrated sustainability metric. It really is that straightforward. If you cut your replacement cycles in half by utilizing materials that last 12 to 15 years instead of 6, you fundamentally alter your environmental footprint, and you vigorously protect your long-term operating budget. You basically stop paying for the privilege of throwing things away. So I want to leave you with this final provocative thought. When your space inevitably changes, and we all know it will your walls generate a masterpiece or just another ton of waste? It's a really critical question to consider before your next commercial project. True expertise means looking way beyond the surface aesthetics to understand the deep life cycle impact of our design choices. I really hope this explainer has given you the strategic insight you need to make the right choice for your facilities, your budget, and ultimately our planet.